Today we're going to talk about Dalton's law of partial pressures. And this law very simply states that the total pressure in a container is equal to the pressure of each gas that's in the container, all added together. So let's look at what we have here. We have gas labeled P1, and this gas has a pressure of 1 atmosphere. Then we have a gas labeled P2, and this gas has a pressure of 2 atmospheres. If I add them together in the same volume, I add up all those pressures, so P total equals P1 plus P2, 1 plus 2 equals 3 atmospheres. So we're just adding up all those pressures together. Let's look at how we would use this law in an experimental setting. Our experiment, or our reaction, is going to be zinc reacting with hydrochloric acid, and it's going to make zinc chloride plus hydrogen gas. And we want to find out how much hydrogen gas is produced. So we can do this using our gas laws, and we can find the pressure of hydrogen gas using this apparatus here. So we have a test tube, and we react zinc with hydrochloric acid right in that test tube. And then the gas is going to bubble up. It's going to go through this tube and go down underneath the water. And of course, we're assuming the gas is not soluble in this water, and it's going to go up into this collection vessel. Okay, and notice hydrogen gas is 2 hydrogens bonded together. That's the 2 white dots. But there's more going on inside this collection vessel. There is water vapor, okay, 2 hydrogens and an oxygen right there. And that comes from the water that we're collecting it through, and that's not part of our reaction. So when we want to find the pressure of just hydrogen gas inside this vessel, we're going to use Dalton's law of partial pressure, which says the total pressure will be this hydrogen gas pressure plus the water gas pressure. So here is our Dalton's law of partial pressures right down here. And once again, it tells us that the total pressure in our collection vessel right here is going to be the pressure of the water vapor and the pressure of hydrogen gas. In order to record our pressure correctly inside this collection vessel, we need to remember how atmospheric pressure is going to behave on our apparatus. So remember, atmospheric pressure is going to be pushing down, and right here you can see it's pushing our liquid up higher inside this vessel than it is in the collection tank. So our collection tank level down here is not at the same level as inside our collection vessel. Recall from our manometer lesson that when the mercury levels on the left side and the right side were equal, our gas pressure equaled the atmospheric pressure. And that's going to be similar to how this works. So what you can see on the left side is that the water in the collection vessel here is much higher than the water inside the tank. So our pressure here is inside our collection vessel is not going to equal the atmospheric pressure. If I adjust that, and you would do that by raising and lowering your collection vessel, and you get the water inside the tank equal to the same level as the water inside the collection vessel, then the gas pressure inside the vessel is going to equal atmospheric pressure, which you can just get from your readings of atmospheric pressure for the day. So here's our problem. Hydrogen gas is collected over water at 25 degrees C, and the total pressure of the gas collected is 560 millimeters of mercury. What's the pressure of the hydrogen? Well, first of all, we need to figure out what is the total pressure here that's given, and we have to remember that our total pressure is that hydrogen gas plus water vapor. So now we need to know what the pressure is of the water vapor. And you would be given this table right here, and this is where we would look up the pressure of our water vapor. Now our pressure, our total pressure is measured in millimeters of mercury, so we're going to use the millimeters of mercury pressure line. And we're going to use Dalton's law of total pressure, which says that the total pressure is the pressure of all the gases in that collection vessel, which is water vapor and hydrogen gas. Okay, so we need to plug in our numbers. Our pressure total given is 560 millimeters of mercury. And then over on this chart, we can see at 25 degrees C, our water vapor pressure is 23.8 millimeters of mercury. So we would plug that in our equation plus our hydrogen gas. So rearrange and you can get the pressure of hydrogen gas. Again, all we did was subtract the water vapor out of that total pressure so we could get the pressure of just hydrogen gas alone.